Okay. Have you guys seen absolute value equations before? You guys seen any absolute value equations? A little bit of that. Yeah, I'm going to probably build on what you've seen before, but we're going to be studying absolute value equations and inequalities. In arithmetic, an absolute value symbol takes a negative number and makes it positive. That's in arithmetic. We're dealing with algebraic expressions, and we have an absolute value. There's a two-part process here. Let's see if I can get this in solving it. What we're going to do on these is try and isolate the absolute value. That means get the absolute value by itself. It's kind of like treating the absolute value. Whatever's in the absolute value bars, we're treating that like it's its own variable. So be sure to write down. So first, isolate the absolute value. And then we're going to split the absolute value into two problems and solve. Yeah. Maybe what I'll do is maybe you can bring your packet and your blue calendar tomorrow. We can just all cut up on these grade whatever needs to be graded. So here's how this works. Say, for example, I'm standing right here. Somebody is walking towards me, right? And there's going to be a point at which that person is 6 feet away in front of me, right? But then they're also going to reach me, and if they keep going past me, and they'll be 6 feet away from me on the other end as well. That's the idea with absolute value. Absolute value is a distance. It measures distance. In this case, like in this x minus 18 equals 5, if the absolute value is the distance from a certain point, in this case it would be 18, because 18 would make this equal 0. So what we're finding are the two values that are 5 units away from 18. So it's in real life, we'd use absolute value to model something like what I just described, where somebody's coming at you, they're going to eventually be 5 feet away from you, and then they're going to pass you and be 5 feet behind you another time. So there will be two places where they are 5 feet away. If you think about a number line, if you're staying at 0 and you want to know, what point is 7 units away from 0, there's two of them, right? It would be -7 and also +7. So because of those two different cases, we've got to split this problem into two cases and solve both of them. And the way we do that is we first ignore the bars and just consider the positive version of this, x minus 18 equals 5. Place an or in there. And the other one is x minus 18 equals -5. That's ignore the bars, use the opposite of everything outside the bars, or on the right-hand side or other side of the equation, if you will. It doesn't have to be right-hand side, but so first you're going to get the absolute value symbol isolated or by itself. So if there are any numbers out in front of it or numbers being added or subtracted from it, you need to take care of that first. You get it isolated first, and then split it into two cases and solve. So real easy to solve once you split it up. Add 18. So x equals 13. So what we're saying is, if I had 18 right here in the middle, let's place 18 in the middle, there are two numbers that are 5 away from 18. They are 23 and 13. Each of them are 5 units away from 18. So if you think about absolute value as a distance away from a certain value, it makes sense that there are up to two solutions. There can be two solutions there. So 13 and 23 are each 5 units away from 18. All right, here's an example of one where the absolute value is not isolated. So step 1 says isolate it. We're going to isolate it by subtracting 2 from each side. So I have absolute value of x equals 7. And this one, notice that x is not paired with anything in here. That means the center in this case is 0. Okay, if I wanted to, I could write x minus 0 in there, but we don't usually. So we have x is equal to 7, or x is equal to negative 7. So I'm finding the two values that are 7 units away from 0. So 0 is right here. It's 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, negative 7. Both of those are 7 units away from 0. And this next one here, the x minus 2 equals 4. Notice it's already isolated, so we split it into two cases. It's x minus 2 equals 4, or x minus 2 equals negative 4. Add 2 to each side. So I have x equals 6, or x equals negative 2. This time I'm going to place the 2 in the middle because, see this 2 right here? I'm finding values that are 4 units. So what values are 4 units away from 2? So place 2 in the middle, count 1, 2, 3, 4 units to the right, that's 6, and 1, 2, 3, 4 units to the left, that's my negative 2. Alright, I think we'll skip the now you try on these. I'm going to skip over these. So we'll just cross those out for today, just in the interest of time. Do you guys see what I mean by the two cases here? And do you see what I mean by isolating absolute value of x before doing the two cases? Is that alright? We have to subtract 2 over. Don't go straight into the two cases. You've got to subtract the 2 over, get the absolute value by itself, then split it into two cases. Alright, so starting from 100 feet away, your friend skates towards you and then passes you. She skates at a constant speed of 20 feet per second. So here's the 20. Her distance d from you in feet after t seconds is given by the equation d equals absolute value of 100 minus 20t. So if you think about this for a little bit, if I plug in 1 second here, she's 100 feet away from me. After 1 second, she's gone 20 feet, right? She's going at 20 feet per second. So if you take away 20 feet from 100, she's now 80 feet from me. After 2 seconds, she would be how far from me? 60. And then after 3 seconds, she would be 40. So you could probably solve it just by doing a little bit of guessing and checking, just trying values in. Let's find both of the values, because she's eventually going to get to me, past me, and then be 40 feet away from me somewhere down the road here after several seconds. Let's see what that is. So take the 100 minus 20t in absolute values, set it equal to 40, and then solve. So I'm going to split this into two cases. Just trying to make the absolute value symbol big enough so it doesn't look like it's a 1. So we have 100 minus 20t equals 40, or 100 minus 20t equals negative 40. Those are the two cases. If I subtract 100 from each side, I have negative 20t equals negative 60, and then divide by negative 20. Divide by negative 20 on each side, I should get a positive 3 seconds, which is what we had figured out as she's coming towards me here. So t equals 3. So that's one of them, is t equals 3 seconds. The other one here, same process, subtract 100 from each side. So I have negative 20t equals negative 140, and then divide by negative 20. So t equals 7. So the other time that she's 40 feet away from you is 7 seconds later. If you put 7 seconds in here, 100 minus 20 times 7 is 140, gives me negative 40. And the absolute value of negative 40 would be 40 feet away from me. Okay, why don't you try this one, the now you try here. Give you a minute to... So yeah, you should have gotten t equals 4 and t equals 28. Alright, this one right here, it should be equal to 10 here. Let me just change this. And this is an example of an absolute value equation with no solution. So remember, absolute value means distance. We're going to keep that in mind as we go through this. The process would be to get the absolute value by itself, right? You see how there's a plus 12 out here and a 3 in front of it? We need to get rid of both of those to get it isolated. So I would subtract 12 from each side. So I have 3 times the absolute value of 2x plus 9 equals negative 2. That's what I have so far. One more step to isolate this. We need to divide each side by 3. And that will cancel out the 3 in front of the absolute value expression. So I have absolute value of 2x plus 9 equals negative 2/3. Now, since absolute value means distance, what I'm asking here is, what value is negative 2/3 away from this particular center that we have here? And therein lies the problem. Okay? Our distance can't be negative. Okay, so when you have an absolute value expression equal to a negative number, because this is distance, and distance can't be negative, there's no solution. There's no solution on that one. And down below on the now you try, there's one of these that when you isolate the absolute value, it gets rid of the negative in it, so you end up with a solution. And one of them, when you isolate it, it's still negative on the other side. So one of these has no solution, one of these has a solution. Could you just figure out which one is which? So the first one has a solution. When you isolate the absolute value, it's equal to a positive. The second one does not have a solution. When you isolate the absolute value, it's equal to a negative number. All right. Greater than. So we looked at equals, so absolute value equations. Now we're going to look at greater than or greater than or equal to absolute values. When you see the greater than or greater than or equal to symbol, it means or in the context of compound inequalities. So last time, do you remember what the or graphs looked like? For the most part, they went in opposite directions, okay, unless they intersect in some way, and then you have the whole number line. But generally, they tended to be going, less than this value or greater than this value. That's what's going to happen here. We have 8n is greater than or equal to 24. Just think of the greater than, and just emphasize the part and make it a greater than. Greater than is or. That's what this is. So we're going to set this up as 8n is greater than or equal to 24. We're going to separate it by an or. 8n is less than or equal to negative 24. So 8n is greater than or equal to 24, or 8n is less than or equal to negative 24. Then just solve this for n. Divide by 8, divide by 8. So n is greater than or equal to 3, or divide by 8, divide by 8. N is less than or equal to negative 3. So notice I flip this and I negate this. And so just make a note of that. You got to flip the inequality in negative. Because of the fact that when we divide by a negative or multiply by a negative, you have to reverse or flip the inequality. So I'm considering like the positive and negative cases here. And when I go to graph it, if I place 0 in the middle, here's what it looks like. 1, 2, 3 is right here. Negative 3 is here. This says n is greater than or equal to positive 3, so it goes that direction. And this one says n is less than or equal to negative 3, so it goes that way. All right, see if you can get the two cases for the second one. The two cases would be. So one of the cases is just as you see it, but without the absolute value, right? That's the one that everybody gets. We're separated by an or. What's the other case? We get for the other case here.
X minus 4 is less than negative.
Yeah, less than -1. That's it. So it's a flip and a negate. And then you solve them. Look like a lot of you are solving it already. Add 4 over, so if x is greater than or equal to 5, or add 4, x is less than or equal to 3. So if I place 0 right here, 1, 2, 3 is here, 5 is here, and we are going greater than or equal to 5, or less than or equal to 3. So this is just like we saw last week with the compound inequality separated by an or. So remember, greater than is or, split it into two cases. Okay, the now you try is really similar to this, so I think we'll skip that. As long as you have the correct setup on this one, I think we're good. All right, so we've looked at equals, we've looked at greater than. The other one is less than. And then we have all three of our different examples. So this word problem will be a less than case. If you could write up here by that less than symbol, this is an and. By the way, it doesn't matter if it has the line underneath it or not, it's still an and. It says a company makes boxes of crackers that should weigh 213 grams. So that might be what's stated on the box of crackers. It says 213 grams. Well, there's going to be a little bit of variation from box to box. Okay? And they usually allow for a certain amount of tolerance. Like they could be a few grams above, a few grams below, and that's okay. If it's a few grams above, or too many grams above on a consistent basis, the company is going to lose business, right? I mean, they're losing money. If it's too low on the other end, people could get upset, and there could be lawsuits for not getting, their stated amount of crackers. People are serious about their crackers, but you never know, right? So you've got to be within a certain tolerance. So it says, quality control inspector randomly selects boxes to weigh. Any box that varies from the weight by more than 5 grams is sent back, or he just eats a few and then close. Eat a few and then close it back up and put it back in production. So write an absolute value inequality to model the situation. What is the range of allowable weights for a box of crackers? You may be able to answer that already, right? If the tolerance is 5 grams, it could be 5 grams above 213 or 5 grams below. But you see how that's a perfect scenario for an inequality. So what we have here is the absolute value of x minus 213. The 213 is paired with the x because that is the center. That's the value that we're looking for. And it has to stay less than or equal to 5 grams on either end. Okay, so this is our setup. These are absolute value symbols. Don't think they're ones here. We'll make them thick maybe or something. So x minus 213 is less than or equal to 5. So my two cases would be x minus 213 is less than or equal to 5, and x minus 213 is greater than or equal to, so flip the inequality, -5. And then solve each one. So add 213 to each side. So x is less than or equal to 218. And here we're going to add 213 to each side. And x is greater than or equal to 208. So if I were to answer this in words, I would say anything between 208 grams and 218 grams is okay. All right, we're going to skip the now you try. I'd like you to go to the summary and to be recorded.